Hello, everyone, and also a warm welcome from my side to a new edition of our PowerTech Virtual Talk series. Today, our general theme is challenges of the EU Green Deal for the machinery and equipment manufacturing industry. And it's great that you're all here to expand your knowledge of the challenges in the Ecodesign Regulation. And it's only 3 months to go until PowerTech, where you can find out even more about this exciting topics in our expert forum right on the spot. And before we start into the program, I would like to thank our partner, the VDMA, for organizing today's virtual talk. Special thanks to Nathalie Wagner and Christine Montigny, who will guide you through the program today. And of course, a big thank you to our 3 speakers who will take you through the session. Lukas Martin, Policy Advisor, Environment and Sustainability from VDMA e.V. European Office. Leonhard Heinrichsmeier, Head of Sales, Chemical Industry, Alexanderwerk GmbH, and Michael Mirsch, Engineering Manager, Precision Fluid OEM, Norgren, Buschjost GmbH. Without them, this would not be possible. And now I hand over to Christine Montigny from VDMA. Enjoy the talk.
My name is Christine Montigny. I'm a consultant for air pollution control, process air within the VDMA, the Association for the Machinery and Equipment Manufacturers Industry in Germany and Europe. On behalf of my colleagues and myself, I would like to thank our host, the PowerTech Trade Fair Organization, for the opportunity to present today's virtual talk on challenges of the EU Green Deal for the machinery and equipment manufacturing industry. The EU Green Deal's goal to make Europe the first climate neutral continent in the world is vast and complex. The comprehensive and consistently expanding package of measures of this goal does not only contain all kinds of plans for the circular economy and a sustainable EU, but also bears challenges for the European machinery and equipment manufacturing industries. This virtual talk will therefore deal precisely with these challenges in the Ecodesign Regulation, offers assistance with a digital product pass, and provides an up-to-date insight into PFAS, or per and fluoroalkyl substances within the REACH regulation. Exactly these effects of the PFAS regulation are illustrated with the example of the valve industry, and in addition, the example of roller compaction offers practical implementation for the saving of resources. First speaker is my colleague, Mr. Lukas Martin from the VDMA European Office. He will present an overview on the current challenges of the European Green Deal for the machinery and plant engineering sector, from the Ecodesign Regulation and the Digital Product Passport to the PFAS restriction. Lukas, I'm looking forward to your presentation.
Again, also for me, a very warm welcome to all the participants, a very warm welcome from a sunny Brussels, which is a rare event here, unfortunately. And thank you for having me today. I hope I can give you some insights from current legislation proposals in Brussels. As already teased, my name is Lukas Martin. I'm working as policy advisor for environment and sustainability at the VDMA European Office in Brussels. So the topic for today is current challenges of the European Green Deal for the mechanical and plant engineering sector. As you all probably know, the Green Deal contains many proposals, and we, of course, do not have enough time to cover all of them today. Therefore, I will talk a bit about 3, the Ecodesign Regulation and the Digital Product Passport. These 2 are related to each other, and another topic is the planned restriction of PFAS that came up quite recently. So the European Green Deal was approved in 2020 by the Commission of Ursula von der Leyen and is, generally speaking, a set of policy initiatives with the aim to make Europe climate neutral. To summarize that, and I really like the quote since it clarifies what a great challenge but also chance the Green Deal is, Achieving the EU's climate and environmental goals requires new industrial policy based on the circular economy. The European Green Deal is our new growth strategy. We will help our economy to be a global leader by moving fast and moving first and moving fast. So what is the European Green Deal supposed to achieve? Main goal is the EU as the first climate neutral continent by 2050. But also to include a European climate protection law, transforming the EU economy for a sustainable future, and the EU as a global pioneer in the circular economy. To make this a bit more comprehensible, we have tried here to split all the legislative proposals in three main sections. We have on the one side the climate section with the very prominent Fit for 55 package. I'm sure you all already heard about it. The CBAM or the Energy Taxation Directive, these are all very important files, of course, but more important for us today is the right side, the circular economy side. As you can see here, we have the Ecodesign Regulation and the DPP I'm referring to today, but also the textile strategy, the review of the battery regulation or the packaging regulation. And then a third section, we have defined some so-called cross-cutting topics such as CSDDD, the Corporate Sustainability and Due Diligence Directive, the taxonomy, and the CSRD. So making sustainable products the norm, that's the credo the European Commission has in mind. The EU already today sets minimum environmental requirements for certain products or sectors, such as energy-related products, packaging, and chemicals. These requirements have helped to substantially reduce the EU's environmental and climate footprint, including energy consumption. However, the existing rules cover only a limited share of the goods market in the EU and do not systematically encourage circularity, nor tackle many of the ways in which products impact the climate and the environment throughout their life cycle. Also, there is still significant potential to lower the energy use of energy-related products. That's why the proposal for Ecodesign for Sustainable Products Regulation is at the heart of this package here. It foresees setting minimum criteria not only for energy efficiency, but also for circularity and an overall reduction of the environmental and climate footprint of products. Until the new framework enters into force, the existing Ecodesign Directive, which we have since 2005, will continue to drive improvements in energy efficiency and circularity. To that end, the Commission is adopting, together with the new proposal, an Ecodesign and Energy Labeling Working Plan from 2022 to 2024, and to cover new energy-related products and update and increase the ambition for products that are already regulated. And to support this, targeted sectoral initiatives, as you can see in the circle, for example, the EU strategy for sustainable textiles are part of the package to address priority product groups that have significant impact on the environment and climate. But to go more into detail about the ESPR, what is the concrete approach of the ESPR? The Ecodesign Directive has, as I already mentioned, has already existed since 2005 and is now under review and shall be converted from a directive into a regulation. Just to remind you, a directive must be implemented in national law in the member states during a fixed time period, usually 2 years. A regulation enters into force immediately in all member states. So far, the Ecodesign Directive has regulated all energy-relevant products. The Ecodesign Regulation shall regulate all products, including all non-energy relevant products with some minor exemptions, for example, for animal food and military products. The those two are not included in the ESPR, but otherwise, theoretically, in the future, all products can be regulated. The Commission will focus at first on textiles, furniture, and ICT products, but also on intermediate products like steel and plastic and polymers. Plus, and here we see major challenges for the mechanical engineering industry, also B2B products will be regulated in the mid and long term. So to get a first feeling of which product framework the Commission would like to regulate first, here is an overview of end consumer products, intermediate products, and the horizontal measures. We in the VDMA are not directly affected by end consumer products, but here, of course, the value chain must be considered because we are affected again, namely indirectly. Take textile machines, for example. In the future, they will have to pass on information about the digital product passport along the value chain. So, for example, the CO2 footprint of a T-shirt has to be shown. And here, of course, it's a question of how much my machine actually contributes to the production of this T-shirt, and so on. So in summary, we in the VDMA will be indirectly affected by the end consumer products. However, we are more concerned about the intermediate products, which are listed here. This is a new approach by the Commission, because up to now, the Ecodesign Directive has mainly referred to end products. Now, materials are also to be regulated, and if this happens, and it looks like it will happen at the moment, we will be directly affected because you use materials such as steel, aluminium, chemicals, etc., plastic and polymers in your machines. At the same time, our machines process these intermediate products and recycle them. So here we are affected both directly and indirectly. And then to the horizontal measures, the Commission's aim here is that where product groups are similar, these horizontal measures can be used. That is above all in the sense of durability and recyclability. For the mechanical engineering, this is certainly not necessarily of direct concern, rather indirect concern, but it will be an issue, for example, for white goods. For example, washing machines, refrigerators, where there should be requirements in terms of durability, repairability, upgradability of these products. However, we have to keep in mind that the Commission has not yet made a final decision on this topic, but we as VDMA advocate against those horizontal measures. Electric motors, for example, are already covered by the Ecodesign Directive today, but are to be revised around 2025, 2026, and then will be newly covered by the ESPR. So the goal is to address products along the entire life cycle, and in particular, it shall improve durability, upgradability, reusability, and repairability. It shall also increase the recycled content in products, reduce substance of concern, enable remanufacturing and refurbishment, shall lead to a high quality of recycling, reduce the CO2 and environmental footprint, increase energy and material efficiency, and most importantly, shall make information public via a digital product passport, which we call DPP. And this leads me to the second point of this presentation. What is the DPP? Generally speaking, it's a structured collection of product-related data with predefined scope and agreed data ownerships and access rights transmitted by a unique identifier. So this is a bit of an unworldly definition, but to put it simple, you have a QR code, a unique identifier, that's what it's called by the Commission, on your product, which you can scan via your phone and see all relevant information about the product. The DPP shall be based on a decentralized system connected to an European data room based on harmonized standards, and there you can see the data and information on the individual product eco-design requirements. The challenge here is that each product has such an unique identifier, not per product group. For example, take washing machine X of manufacturer Y. Each washing machine has an unique identifier, although it is the same model. So here at the bottom, you can see that a QR code would be placed on the washing machine. You scan the washing machine and can see the information. In practice, it looks like each product is provided with the so-called data carrier. This must then be scanned via a QR code, and the URL takes the user to a website where all product relevant information can be viewed. However, it is important to distinguish between the data that must be entered into the DPP on the one side, in sense of environmental and sustainability data, for example, substances of concern and ecological footprint, etc., etc. You can read this here on the right side of the slide. Plus, who is the economic operator? So who is the manufacturer and distributor of the product? And on the other hand, we have the DPP system. So the actual digital infrastructure of the DPP. This should be based on standards and protocols, and is also this central exciting point for us, because here we are with the concept of the local data storage system, which you can see here. For example, let's put electric motors as an example. You are the manufacturer, the economic operator. You bring it into the market. Then you have to set up this so-called local data storage system. In concrete terms, this means that you have to store all the data and information for creating the DPP there. You also have to maintain this data, and you have to give access rights to the data. So if, for example, the engine breaks down and a third party repairs it, you have to make sure that the third party who repaired the engine has access to the DPP so that he can enter his information there. And you have to provide information on the life cycle so that people can see how the product can be recycled properly and how as many materials as possible can be put back into the material cycle. So from an SME perspective, this is a huge challenge for you, setting up this data system, collecting data, ensuring the security of data and giving access rights is no small task. And in addition, there is the so-called registry, this yellow paper here. The Commission and also the member states see great potential here to strengthen market surveillance via the digital product passport. So in concrete terms, this means that there will be a so-called registry where the manufacturer, as you can see from the arrow, will enter information that only the market surveillance, the Commission and the member states will be able to see. It would make more sense if this arrow went from local data storage to the registry with a linkage of the data system. The registry would get its information to see whether a product is compliant or non-compliant. Otherwise, as currently planned by the Commission, as shown on the slide here, it would have to function as interoperably as possible so that certain data can also be generated automatically. Yeah, but this is we will only see in the future. This is not set yet. This is again to illustrate the example of a pen. I would scan the QR code on the jeans pen, come to the local data storage system, and can view all the information there. And here we see again that the manufacturer is the one who enters the data into the local storage system, manages it, gives access rights to third parties, and has to collect and feed the data. Here you can see the latest considerations of the European Commission on how the TPP shall work in the future. Important to highlight here, information must be mapped up to tier 2 level, at least. This is the latest information we have from the Commission. And to summarize it, the DPP shall ensure information on warranty, the CO2 footprint and environment footprint, labels, compliance, substance of concern, and shall help to improve the durability and make information public that you and me can trace about the product. So in the whole topic, we currently see the battery regulation as a model for everything that will come under the future Ecodesign Regulation. What was done here? There was a battery directive, which was transformed into a battery regulation, so the same system as we see with the ESPR. This sets new requirements, especially with regard to electromobility. The battery regulation was in the trilogue last year. So in the negotiations between the European Parliament and the Council and the Commission, an agreement was reached there. And here we see a full declaration of a product. So from carbon footprint to minimum recycled content, to sustainability information, end-of-life management, due diligence requirements, material restrictions were agreed there. And batteries are so interesting for us here because they will be the first case for this digital product passport. From the entry into force of the regulation, manufacturers have 42 months to fulfill the requirements and to prepare the DPP, the digital product passport. Otherwise, they will no longer be allowed to place batteries on the EU market. And this is therefore so interesting for us because it will be the first to show us what the first DPP on the European market will look like. But the DPP is also a great chance for the mechanical engineering industry. It will probably create new business models, as you can see here on the slides. For example, it will enable manufacturers to create products, digital twins, embedding all the information required either by or by customers in B2B transactions. Or you support the due diligence efforts by tracking raw materials extraction and production. This will also be a great topic in the future because without going too much into detail, the Commission has published its Critical Raw Materials Act in March this year. This is a set of actions to ensure the EU's access to a secure, diversified, affordable and sustainable supply of critical raw materials. So here is a great potential because the ambition by the Commission is high to become independent from third countries and in particular from China. Or a third example you can see on the bottom right here, allowing citizens to have access to relevant and verified information related to the characteristics of the products they own or or are considering to buy or rent using apps able to read the identifier. So the digital product passport entails both challenges, as I have explained, but also great potential for chances also for the mechanical engineering sector. So in the past minutes, I spoke much about the regulatory side of the DPP, but there's also the technical side. So how will the DPP technically be designed, and the standardization side. The Commission will issue a standardization mandate to the European Standardization Organizations, CEN and CENELEC, so that standards and norms for the implementation of the requirements for the DPP can already be developed. At the same time, the technical level is also exciting here. There is the so-called SURPASS project, which is a European funded project for which 3 pilot sectors are to be developed as conceptualization of product passports. These are batteries, textiles, and ICT products. The SURPASS project will run until March 24, and its core tasks is to hand over a kind of roadmap to the Commission, which the standardization organizations should also look at. Lastly, I want to show you the planned timeline of the ESPR DPP here. The proposal was published in March 22 by the Commission. There was a public consultation on the first ESPR work program, especially on which product groups will be regulated first. This was due in May. We from VDMA have participated here, of course, and we criticized the horizontal measures and advocated for a product-by-product approach. We were also critical regarding intermediate products under the ESPR. For us, it must be clarified how the regulation of intermediate products could work in practice and what responsibilities users and processors will have in light of the digital product passport. The Council has set its position in May. The lead committee, the Environment Committee, the ENVI of the European Parliament has voted recently, and the whole plenary is expected to vote in July to set their position. After the summer break, then the trilogue negotiations can start, since both sides, from the Council side and from the Parliament side, their positions are set. So the trilogue negotiations can start. The Commission expects a trilogue agreement in December. This is very ambitious, but it is the current plan. So as I mentioned, the regulation proposed a framework, and the details will be regulated then by delegated acts by the Commission. So in 2024, 2025, we will see the first delegated acts for product groups, for example, for textiles or pumps. And these requirements would then apply from 2026, 2027. And these products could then also only be placed on the EU market with a digital product passport. But it is important here to highlight that when your product are not regulated under the ESPR, you will not be required to make DPPs. This only applies when your product is regulated under the ESPR. So to conclude and summarize here, in the short term, the mechanical engineering industry will be directly affected by the ESPR for products that manufactured, processed, and recycled on and with mechanical engineering technologies. And for products and components used by the mechanical engineering industry and for which eco-design requirements apply, and by the DPP by transferring information and its processing in the value chain. And the mechanical engineering industry will be directly affected medium to long term by possible direct circular economy and sustainability requirements for B2B products, and by transparency over the entire life cycle, also for B2B products. Plus, the Ecodesign Regulation is a framework regulation. It doesn't initially impose any specific requirements on manufacturers, but regulates which products may be regulated and how. From this, product-specific implementing regulations are created. Okay, this is a highly complex issue, and I hope I have been able to give you a bit of an understanding of what the opportunities and challenges are here. But we have to speak about another topics that came up recently, not only in the Brussels bubble, but also in the media, and which will have an enormous impact for the mechanical engineering industry, the planned PFAS restriction. As you can see here on the slide, the debate is massively heated by the media. You can read here words like Bedrohung der öffentlichen Gesundheit, Alltagsgift, and Verschmutzen, and so on. But what are PFAS? PFAS are any substance that contains at least one fully fluorinated methyl or methylene carbon atom. We can see here that PFAS are the superior group, and we can differentiate between two categories. On the one hand, we have non-polymers, and on the other hand, on the right side, we have polymers. And within these categories, we have to differentiate even more, because we can separate them into classes. So on the non-polymers side of PFAS, we see the class of, and please bear with me if I mispronounce these words. We have perfluoroalkyl substances, which are compounds for which all hydrogens on all carbons except for carbons associated with functional groups have been replaced by fluorines. Another class is polyfluoroalkyl substances. And on the polymers category side, we have classes of fluoropolymers, perfluoropolyethers, and side chain fluorinated polymers. So PFAS are the overall group and can be distinguished in categories, and each category has classes. Worth mentioning here, there are at least 10,000 PFAS, so a huge amount. And what are the characteristics of PFAS? And we will probably hear more about this in the next presentations, but I want to show you how many useful and important characteristics PFAS have. So what are the advantages? I don't want you to read them all, but for example, PFAS are pressure resistant, abrasion resistant, mechanical resilient, temperature resilient, and so on. All characteristics that are important for the mechanical engineering industry and have a great impact on the mechanical engineering industry. So the ECHA, the European Chemicals Agency, has recently published the PFAS restriction proposal in February. This means it's not in the ordinary legislative process in the European Parliament and the Council, but under review by the ECHA. This means our impact on influencing this process is restricted. However, the ECHA seeks input from stakeholders in a public consultation, which is due on 25th of September this year, which is massively important since the ECHA wants to restrict all of those 10,000 PFAS. So there are at the moment 2 options: a complete ban with option 1, and option 2, ban with specific exemptions, as stated in the proposal. And the dossier submitters from the ECHA have preferred the option 2, and 5 member states, including Germany, have also proposed this option. On the column on the right, you can see how the actual jurisdiction, the actual jurisdiction will look like, without going too much into detail. But ppb means parts per billion, so 1 microgram per kilogram, 1 billionth to be applied 1.5 years, so 18 months after entry into force. This slide shows non-time limited and time limited exemptions. E.g., for example, the mining industry, you can see here at point F, all applications would have to comply only 13.5 years after entry into force. The mechanical engineering sector is unfortunately hardly shown. It was taken into account in some areas, but not in all. And we are, of course, very dissatisfied because there are not enough exemptions, and we want exemptions for entire capital goods sector, but at least for fluoropolymers, which is the most important sector that can be found in the mechanical engineering industry. So what is the timeline for the restriction proposal? The proposal was made available in February. The consultation has started in March and ends in September. I've already said this. We are currently before the ECHA's committee's evaluation. Next steps would include that the ECHA's committee adopts their opinions and sends it to the Commission. And in 2025, then the restriction could entry into force. So therefore, it is so important for us that our voices are heard in the ECHA. The public consultation is currently open on the ECHA's website. VDMA will, of course, participate in the consultation and raise our critique, but it's also important that you also participate in the consultation. Your participation is urgently needed, because only then we can illustrate the broad scope of concern. It is important that as many stakeholders as possible contribute in order to put pressure on the ECHA. So in the consultation, you can show where your company is specifically affected, and it is important that you make clear to ECHA which fields of application would no longer function under the PFAS restriction. Please justify here in detail for the respective files of application and support your arguments with documents, but keep in mind, it's not mandatory to submit concrete scientific studies to justify the effectiveness, but the justification should be presented as specifically as possible and plausible, of course. For our VDMA member companies, we have published guidelines, articles, and our position paper, both in English and German. If you need more information or help here, the position paper can be also accessed even when you're not a member, but the guideline, for example, and the article is for our members only. But as I said, your participation is urgently needed, and if you have questions, if you want our help, and if you want more information, then please reach out either to me or our colleagues, especially Alena Knautz, which is my colleague, she's our expert on PFAS. And yeah, your participation is urgently needed. So that should be my last words. Thank you very much for your participation and listening to me, and thanks again for having me.
So thank you, Lukas, for your interesting talk. So now it's up to you, dear participants. If you have any questions, please feel free and use the F&A button. I just stopped sharing the screen.
Are there any questions, Ms. Albrecht?
Yes, there is a first one. What do you expect? When will the first B2B products being regulated under the ESPR?
So we expect primarily the B2B products that are already regulated under the Ecodesign today. For example, industrial pumps or electric motors will be the first in the B2B sector to be regulated under the new Ecodesign regulation. And here probably with the first wave of regulation by 2026, 2027. And maybe in addition, industrial washing machines, for example, are currently under discussion. So yeah, probably with the wave of regulation by 2026, 2027.
Okay, thank you. So then there is another one. What kind of eco-design requirements are probably foreseen for B2B products?
Definitely improving the durability, reusability, upgradability, and repairability of products, increasing the recycled content in products, further substance restrictions or even bans, for example, substance of concern, enabling manufacturing and remanufacturing, refurbishment, high quality recycling, calculation and reduction of the CO2 and or environmental footprint, or increasing energy efficiency.
Okay, because I have the look on the watch at the moment. So one last question, and dear participants, if you have further questions for Lukas, just feel free and write an email to pautech@nürnbergmesse.de, and we will forward your questions to Lukas. So, but now for today, one last question. Let's see. Does each product need to have an individual DPP or per charge?
So as I mentioned in my presentation, each product needs an individual DPP. So when you take washing machine X of manufacturer Y, it's the same model, but each washing machine needs an individual DPP.
Okay, thank you very much, Lukas. Christina, I would forward.
Thank you. Yes. Our second speaker, thank you, Lukas, very much for the overview. And our second speaker is Mr. Leonhard Heinrichsmeier, Sales Manager, Chemical Industry, Alexanderwerk, who will focus on the increasing the efficiency of resources and thus providing an integral view of roller compaction. Roller compaction is a method for granulation of powder, which influences the material behavior. And the compaction process itself offers some advantages and compared to other granulation techniques. I'm happy to hand over to you, Mr. Heinrichsmeier.
Thank you, Christine. Thank you so much. And also thank you to Lukas for a very good presentation. Let me see with, okay. Is it possible to see my presentation right now?
Yes, we see your presentation, but not in the presentation modus.
Okay, now it should work. Do you see it in the presentation mode right now?
No, currently
Okay.
not.
Okay, I'm an old man. Sorry for that. Let me see.
So now we just see the blue screen.
Okay, okay. Let's see. I do have some difficulties. Sorry for that. So many screens on my anyhow, I can also maybe if it will not disturb you, I do the presentation like that. So I start with yeah, my first page. So I want to talk a little bit about the EU Green Deal challenges with machine manufacturers. So first of all, machine manufacturers are a little bit special because we have machines who are typically in operation for more than 30 years. And even after that time at the, let's say, first purchaser, they will be sold at the second-hand market. So it's, I still remember once I was in contact with a customer, he told me, oh, you know, I bought a machine from your company at a second-hand dealer, and he gave me the number. I said, hey, that's great. It's a great machine. It was manufactured during the Olympic Games in Munich in '72. That can happen, and it's quite normal. And but anyhow, yeah, today I want to talk, first of all, introduction of Alexanderwerk, then the process engineering, that our process itself, it's a low energy consumption process. It's a very efficient method of granulation. We have some special devices in our machines which helps us to be better comparable to other companies. I want to talk a little bit about mechanical engineering, and Lukas already mentioned the use of efficient motors and frequency converters. So thank you, Lukas, for that. It was a, let's say, a little introduction and also one of my topics. We have low water consumption, and we also reduce, let's say, the use of human resources by modular design. And finally, I will end with the state promotional program. So Alexanderwerk. Alexanderwerk is or was established in 1885. So the former owner was Mr. Alexander van Nama, and we are, as far as I know, one of the companies at the stock market who are listed for the longest time. So first listing at the stock market was in 1899. So we have more than 130 years of experience, more than 70 years experience in compaction and granulation. We are the inventor of the vertical roller design. Of course, we have references all over the world and more than 7,000 machines installed. Here you can see a little bit our distribution all over the world. So in North America, South America, of course in Europe, and in India and China. We are dealing, or our machines are sold in different markets. For example, pharmaceutical, we are very strong in pharmaceutical market. So as an example, you can see here the effervescent tablets. Chemical industry, we already spoke about batteries. So our machines are typically used for granulation of battery materials before they pressed into batteries. So salt is one of our products we produce with our machines. Maybe someone who has a dishwashing machine has material from our machines filled into his dishwasher. So it's something for the water treatment. Fertilizer industry, soda ash, and also silica industry. Silica is what a lot of people don't know. It's one of the components in tires. So car tires contain a lot of silica. And of course, also the nutraceutical and food industry. Process engineering. We are better than wet granulation when it comes to the energy consumption. Just as an example, so the power consumption in a roller compactor is something about 10 kilowatt hours per ton. So if you want to granulate 1 ton of powder, you need about 10 kilowatt hours of electric energy. What a wet granulation, and there it's just an example. So for example, if some materials need more water, some others need less water. But typically, so I said 10% of water, something typical. When you want to dry out that, you need just by the enthalpy 62 kilowatt hours per ton. This is just only physics, so nothing special. So you need more than 6 times more energy just for doing the same, getting a granule. What we do, we press powder by forces to achieve granules. When you do that with liquids, it's just you spray liquid on a powder and then you dry it out. So just by physics. So now I come a little bit more closer to the machine itself. What you can see here is the Alexanderwerk roller compactor. So we have 2 rollers, and we have a feeding device with a screw inside and a stirrer above that the material will not bridge to feed very good into the screw. Then a so-called flake comes out here, will be crushed with a so-called flake crusher, and then enter a 2-step size reduction. So finally, you will get some granular material. Something what we have, what is special. So typically we control the process. Controlling means we have a hydraulic system. So both rollers are put together by a hydraulic device. So with the hydraulic device, we limit the forces. So if we press too much, the gap will just open up a little bit, and then we have exactly the same forces again. Because coming from the side, we don't have any powder leakage into this direction. The powder will fall this way. So we have the possibility to separate it here. It's something which is very typical. There are other companies where their systems are built up in a different way. We have the possibility to reduce the fines, and we can also process with very low material quantities. So especially when it comes to R&D, this is very important. Oh, I just see I have this page twice. I will not tell everything again. Sorry for that. So here you can see it in more details. Also, one of the big benefits of our system, we call it the combi vent feeder. You feed in the raw material here, and here maybe some recycled material from screening will be fed in, or we use it just for venting. So the point is, when you feed in material here and dose it into the roller compactor, you typically have to remove the air which is inside the material. And so we have the possibility to remove the air at this side. So we press it more and more, and the air has to go somewhere. And this is a typical way. It's a very efficient way of deaeration. And in case of, let's say, feeding with undersized material from here, it's also something we convey the material with a screw into the right direction. And so this is not filled at the beginning. So if we fill in here recycled material, the screw is, let's say, 10% or 20% already filled before the raw material comes. So this gives us a chance to have very, very fast, stable conditions compared to other technologies. Just some improvements at the machine, which will help to have really big benefits. Here you can see the other very important feature. We call it the diagonal design of the rotor granulator. So this is the well-known design, which is on the market for, I think, more than 70, 80 years. And we put this at the diagonal design. So this is an angle. We have two different angles of 30 and 45 degree. The biggest advantage is we turn into one direction, so clockwise, and the material comes from the top. In this design, you will have always a force here from the rotor, which moves the material up a little bit. So that's not very good because it's the material by gravity will go into this direction, and the rotor will prevent that the material comes to the screen where it will be crushed. And the point is, with the diagonal design, the material comes here and it will be just accelerated into the right direction. This is a big benefit, especially when it comes to higher speeds. Sometimes it's required when we need to crush a material down very fine. Then the speed needs to be increased. With this design, it is impossible because otherwise a material layer, I call it always a living bridge. So it's like a cloud of material which will turn around above the rotor and will prevent that material can fall down. And with this design, we don't have that. Of course, there are also solutions if you have a design with a normal rotor, so you need to stop. For example, you can do something like oscillating and just oscillate, but oscillating means also you stop to zero. And that means you lose time and also throughput. This is now something also Lukas mentioned before. It's just a regulation about eco-design and the motor. So we use high efficient motors in case of explosion-proof design. And in case we don't have explosion-proof design, we use super premium efficient motors. So it's much more efficient, and we still use it. We use it for many, many years. And it's really something where I see a challenge because we deliver worldwide, and even some countries in Asia, for example, South Korea, they had this regulation, let's say, a few years earlier than Europe had. And we always use inverter technology for changing the speed of our machines. So inverters have to be energy efficient class 2. Sometimes by friction, we create some heat in our roller compactors. The typical way of Alexanderwerk was just right from the beginning to use a recooler, so a chiller for cooling everything down. Of course, when you think about CapEx, so the investment cost, it makes more sense just to use tap water to cool everything down. But when you do the same, I have here an example. A chiller for 250 to 300 liters per hour uses 3 kilowatt. Otherwise, you would have just wastewater, which just only heated up. Some industry do it like that. Our system is different from that. I also want to talk about modular design because we have to adapt our machines according to the materials of the customer. Every powder is different. Just if you think about, let's say, household, if you compare to wheat flour and sugar. Wheat flour is a material which will just build up a vertical wall and sugar just will flow. So it's totally different. And of course, our machines who are dealing with powders have to be totally different. By modular design, we limit the engineering resources, which are human resources. We also limit resources in the production and manufacturing process to save energy, time, and everything. So we have a very high demand on individual requests in design, control, and process equipment. For example, customers just have things like a password guideline. So we have to, as a machine producer, we have to discuss with them how to use their passwords when they do a login into our machines. And so it can be sometimes very, very complicated based on their requirements. So we do reduction of production costs and reduction of lead time. At the same time, we want to be very flexible and fulfill the customer's demand. There's also a state program I want to talk about. So for example, the KfW in Germany, of course it's only Germany, replacement of new or cross-sectional technologies. So I put also the link inside. Of course, it's impossible for you to follow the link, but if you're interested, just send me an email over the Nürnberg Messe. Again, this program starts at 2,000 euros. And optimization is possible up to 20,000 euros. Modernization in case of energy reduction of 10%. If you just think about what Lukas mentioned before with the motors, it's really this thing. So you can replace a motor and get also some money back. And yeah, so there are many things. So for example, here's also the KfW energy efficient program for production systems and processes, but there's also something from the EU. And yeah, I would really like to invite you to help to protect the environment by doing something like that. A small summary of what I told you before. So Alexanderwerk is a supplier of roller compactors for the pharmaceutical and chemical industry. The dry granulation process requires less energy than wet granulation, which is something in the pharmaceutical, which is standard. The control of the process with our CombiVent feeder reaches faster, stable conditions and has a better product in case of very small batches. With the diagonal design, we produce less fines and have a more efficient granulation. Just if you think about, in our process, it's quite normal that we are able to recycle the fines from the granulator. And so if you produce 10% less fines, it means also at the total energy consumption, 10% less energy. And it's just only by the design of the machine. And I think that helps a lot. It will not cost you more. It just look for a very efficient machine. The use of efficient motors and frequency converter is also very important. And we have almost no water consumption, which helps us to save fresh water. The human resources are also reduced by modular design, and there are promotional programs available. So thank you everybody for listening. I did it very fast because I thought I need to speed up a little bit. I hope everything is understandable, and I'm now open for any questions.
Thank you very much for your interesting talk. So now, dear participants, if you have questions, feel free. Okay, so Leo, I would say we start with your questions I sent. What is the difference between horizontal and vertical aligned rollers?
I need to figure out again my problems in the presentation. Sorry for dealing with old men. Let me see. I need to show it. Anyhow, I try to do it. I try to do it in the normal way. So when you have horizontal aligned rollers, they are in this design. So you have one roller at, let's say, 3 o'clock and the other at 9 o'clock. So material comes from the top, and also the gravity comes from the top. And when you see the vertical aligned rollers, you just look in my back. So one is at 12 o'clock and the other is at 6 o'clock. And we have the feeding screw coming from horizontal, and the material will also come from this side. But the gravity, of course, on Earth, we have gravity always coming from the top. That's one thing. Just to explain a little bit more about that, with horizontal aligned rollers, I think it's the eldest design for roller compactors. The feeding is helped by gravity, and you typically have a one screw feeding or even only gravity feeding. There are also some disadvantages. So it's sometimes uncontrolled feeding because you have the gravity always, so you cannot switch off gravity. You have a powder leakage due of gravity, and sometimes also uneven material distribution on the roller surface. I think one really good advantage of the vertical aligned rollers is that you bring the material from the horizontal. Oh, let me just see. No, with the picture in my back, it's from this side. You bring the material from the horizontal, and the flake is also transported horizontal, and the gravity is from the top. So we had one thing where we also had been asked by a chemical company to do something like dewatering of plastic, so of polymer. And the big advantage was, so the water is something you cannot influence. The water will always drop down, but the dewatered material went to the side. And this is something, especially when it comes to dewatering, it's a very, very efficient thing to work with vertical aligned rollers. Do you have some more questions?
So thank you. So because I have a look on the time, if you have further questions to Leo, please feel free and write an email as pronounced before at powertech@nürnbergmesse.de, and we will forward your questions to Leo. Thank you very much. And now I hand over to Christina again.
Yes,
yeah,
thank you
so
Leo.
much.
Yes, thank you. And I'm sure everybody can take the chance to visit you at your booth at the exhibition. Our third and last speaker this afternoon is Mr. Michael Mirsch, Engineering Manager of Buschjost. And in his presentation, Mr. Mirsch will illustrate the PFAS registration's impact on the valve industry. And as a manufacturer of valves, Buschjost considers itself as directly affected by the announcement of the proposed PFAS restriction within the framework of the REACH regulation. So we'll see what the challenge is for the company. And Mr. Mirsch, you've got the stage. Thank you.
Thank you very much. So just let me share my screen very quickly. Hope you can see it by now. Can you see my screen?
No, we see you.
Well,
yes.
Not
no.
as intended, but at least a bit. Better now?
Yes.
Good. So yeah, as introduced briefly, PFAS hits us as well, but who are we first? So let me give you a brief overview of our company. So Buschjost, Norgren, IMI, Precision Engineering, who's that? In a nutshell, Buschjost is part of Norgren, Norgren part of Precision Engineering part of IMI. IMI is a company, global player in valve technology, automation, and HVAC, for example. Has roughly 2 billion in revenue, 11,000 employees across the globe. I'm not going into detail of this, just to give you an overview. Okay, we're basically everywhere you could act as a manufacturer of valves, for example. Looking at Precision Engineering, which is our part, we're roughly 5,400 employees for the time being. Buschjost is placed in Bad Oeynhausen, a lovely area in Germany. We have roughly 300 employees. We have a tech center, including laboratories, R&D. We have manufacturing, on-site, administration, sales, anything you need to be operating efficiently and at pace. Buschjost, which is interesting to know, has a very high vertical integration. So our value add is roughly over 70%, which if you think about PFAS and our supplier base, really relies on suppliers who deliver us with raw materials, for example. So like casted iron parts or injection molded parts or rods or forged components, for example, but also when it comes to sealings, so O-rings, gaskets, but also raw rubber that we vulcanize into final sealings. As part of Precision Fluid OEM, in Norgren, our key segments are basically food and beverage, agriculture, firefighting, compressors, environment, where we consider us with our tank systems and dust filter valves being one of those companies that should be on the power tech every year. So, but also we produce components that go into mining applications, so very, very freaking big machines where we put in our valve technology. Buschjost provides all kinds of valve technology for such applications as said, the dust filter valves, for example. Let me see if I have a pointer directly. So there's a pointer, as you can see. So dust filter valves, for example, which is basically what we would exhibit on the power tech later this year. But also stuff like externally actuated valves or pneumatic actuated valves, proportional valves with stepper motors, manifolds, combined systems, integrated solutions, and also valves for high pressure applications such as hydrogen refueling stations. Dust control, as said, as a brief introduction to what we later present to you on the power tech, large tank systems, integrated solutions for cleaning off dust of certain applications as such, and also single valves in the end. Looking at the time, and I know that you're all waiting for the Q&A in the end, I hope. I'm not going too much into detail what we provide to you. So on PFAS, so where in our products does PFAS hit us? Basically, as a valve manufacturer, we are heavily dependent on sealing technology, making sure the valve actually is leak tight, externally and internally, of course. Therefore, obviously, we use sealings, O-rings, gaskets, whatever. I just provided you with one basic random application we have, or basic product we have. This, for example, is being used for cleaning off urea on commercial vehicles. So basically, we use O-rings on the inlets, on external sealing points, but also gaskets like diaphragms and sealing plugs to provide internal tightness in the end. Depending on the application or on a product, those sealings could be made of FKM, for example, FPM, which are heavily used in PFAS. there's a good reason why we use those materials, as stated by one of my colleagues who provided you with their presentation earlier today. FKM, for example, PTFE, PVDF are great materials when it comes to severe and critical applications, temperature ranges, chemical resistance to acids, alkaline fluids. Temperature range is another topic. FFKM, for example, when it gets really low in temperature. So by restricting PFAS, and therefore the outcome of those materials like FKM, PTFE, PVDF, for example, we are in trouble. We have to figure out which materials we can use in the future as soon as the restrictions actually hit us. So just to give you a rough overview of which components or which materials we're looking at, FKM is used for sealings, O-rings, and gaskets, like in this place, in this place, in this place. PTFE, not covered in this cross-section view, unfortunately, but still used for guiding rings. PTFE, especially if you have a bit of coal inside, is a great partner when it comes to gliding applications and bearings. PVDF as a great opportunity, or great candidate if you don't want to use stainless steel because of weight, waste, and cost price in the end. If you look into injection molded solutions for valve housings or covers. So basically, in nearly every product of ours, some of those materials could be used. And there are alternatives like EPDM, NBR, HMBR, whatever, but they all have to fit to our customer's application in the end. So the customer requirements are crucial to what we do. So how do we face that? Basically, it's a three-stage approach, more or less. So obviously, we need to stay close to our supply base and with our customers. The very beginning of it all is, as with everything that is restricted by REACH, we have an external database. So we use an external database run by an external company that is aware of all of our bill of materials, basically, and which kind of materials we use and by whom we source them. So they know, for example, our suppliers. By figuring out and asking our suppliers based on the material we use, if there are any chemicals that fall under the restrictions of REACH, for example, we figure out in which product we actually have those chemicals, just like PFAS now. We get reports monthly. We can gather them manually at any time. And therefore, we know quite well in which products we have such challenges. So first, identify where you have the risk, the REACH execution in the end. By that, you know with which supplier you have to talk. So we basically talk to our suppliers, ask them for their strategy in the end. So basically, again, executing REACH, make sure you get through your supply chain and basically find materials that are restricted in the end. So asking for their challenges or for their strategies, like, is there other components, other materials that could be used? Is there some kind of recommendation already? Like in this case, instead of using that FKM, maybe you could use that HMBR, whatever. Take that as an information and evaluate in the next step in selection the customer requirements. So stay close to your customer. Basically, know the application, no restrictions, no requirements in the end, like temperature ranges, like chemical resistance that is required based on the operating media, etc. And therefore pre-select candidates. I think we all can relate to supply chain issues that the world has seen over COVID. And therefore we're a bit trained when it comes to, okay, well, we need to figure out how to qualify products in the end. Find alternatives, qualify them, and make sure to meet our customers' requirements. So in a nutshell, evaluate the risk with the supplier base, stay close to your suppliers, identify possible alternatives that are free of PFAS, if there are any, Make sure to pre-select a bunch of those alternatives, better 2 than 1, to make sure your supply chain is stable. Double check, cross-check that with your customer requirements. Set up a DVP so you know how to qualify those products, have lifetime tests, have, I don't know, like migration tests, for example. Make sure you meet overall regulations in case you're talking about food safety, for example. Make sure you get an alternative that is also food safe in the end, so that you don't fall into the trap to have a technical solution that is not fulfilling regulatory issues. Make sure to run the DVP where reasonable, if there are reasonable alternatives, and in the end, change material. So basically, information is key. Know your customer and stay up to date. Also there, we stay close to what the VDMA is figuring out and providing information. Make sure to be broad in your knowledge. As said, we are a company with roughly 11,000 employees all over the globe. So we do network not only externally with our suppliers, our customers, and of course institutions like the VDMA, but also when it comes to our fellow colleagues in the group. So basically, that's more or less. I really tried to compress what I was about to say in like 10 minutes now, Aish. So if you have any questions, please use the chance now.
So thank you, Michael.
Welcome.
If there are any questions, please feel free and use the F&A button. So I can see a first question. Why are you using materials like PTFE, and why is it so hard to find alternatives?
Okay, so as said before, so our material selection is heavily based on the customer requirements. So, for example, finding an alternative for like bearings or guiding rings is quite tough. So we are looking at some of those alternatives, like PEEK, for example, but we already see that those have less performance in the end for our products. So you fall into the trap of doing some kind of basic research, which takes time, and in the end, qualification plans are quite severe. So it's not always the case that you have this one product that there's only one customer is buying with this one application this valve is falling into. You have a variety of products and applications, and all of a sudden you need to figure out what's the toughest one. How do I solve that? So we're looking at products that have been qualified 20 years ago-ish. Therefore, running all that qualification again of a customer you might not know anymore because it's just way too long ago, that's quite challenging. So figuring out what's the requirement in the end of your customer can take time and effort.
Okay, thank you. There's another one. What's the quality of your gathered suppliers' feedback so far?
Spread it. Some customers, some of our suppliers return with actual like instead of using that, use that. We took a brief look at your specification, like temperature ranges, pressure ranges, mechanical loads, etc. Pressure sets, whatever, and this particular material, like, I don't know, like PEEK or HMBR, MBR, whatever, could solve the issue. That's usually some better feedback that we receive. At some point, in some cases, we just get feedback that we would say to our customers as well, like, okay, this is a new information more or less. We're just waiting. We're waiting for what is happening as soon as the ECHA is done with their investigations. So it's playing a waiting game in the end. So the quality of the feedback we receive is spread. Like from we have alternatives, or we're looking at alternatives, to now we'll see what happens in a couple of months. So the stretch is quite far.
Thank you very much, Michael. So I would say that was a precision landing right now. Thank you for your insights and your talk. We're at the end of the virtual talk now. So thank you all participants for joining us today. And if you're interested in the upcoming dates for the virtual talks, just visit powtech.de or follow us on our social media platform, LinkedIn. And yes, stay tuned and feel free to join us again. And maybe we see us in person again in September from 26 to 28 here in Nuremberg. Have a nice day and see you soon. Bye-bye.